Hi gents, we're going to have a quick little look at some geometries here, different types of geometries as we do them. This is from 2018 and it's paper 2 and it's question 12. So the diagram below shows a Horcrux. It says ABC is an equilateral triangle. So first of all, I want you to think, what is an equilateral triangle? What are the consequences of it as well as just what it is? So it means all sides are the same. If all sides are the same, it means that all angles are the same. Why does it have to be 60? So can you pause and just prove to yourself that of course it has to be 60? Well, if all of them are the same, call each of them theta. And it follows that theta plus theta plus theta is equal to 180 because there are three angles in triangle. So just a little bit of algebra. Divide both sides by 3. Theta is equal to 60. Okay, so far so obvious, but what we're going to do is we're going to have a look at the different types of symmetry. So we mentioned these before, but just it's been a long while. So let us we'll use L, the letter L. Okay, and we'll talk about different types of symmetry. So one type of symmetry is central symmetry. So that means symmetry through a particular point. Okay, so what's going to happen is, we might use yellow here. This point here goes straight. So this the end part of L goes straight there and straight out the same distance and direction. So this is what's called the image. So if we take this, we call this thing A, this would be A dash, or the image of A. So that's where A ends up. If we were to take this point here, we'll call it B. This is central symmetry, meaning symmetry through a point. You send it through the same point, back out the same distance and direction. There's B dash. And finally we've got C. Goes through the point and ends up, I would say, roughly there. There's C dash. And what you end up with then is you end up with this. Okay, so this is the image of it under central symmetry. Okay, central. What's the equivalent of it doing as well? If you were just to talk about it in rotation, what are you rotating it? So it's 180 degrees either direction, obviously, because 180 degrees will counterclockwise or clockwise brings you to the same place. So this is what's known as central symmetry, and that is what happens during that. It's like rotating it 180 degrees. Okay, let's look at a different type of symmetry. We'll look at axial symmetry. So this is symmetry through a line. Symmetry through a line. We'll put the line there. The line, it could be this line here if it wanted to be, but we'll just put it here just for the time being. Okay, what is going to happen in this case? Well, A is going to go directly to the line. Okay, when I say directly, I mean at right angles. That's what I mean. So this would be A dash here. C, I'll just kind of go a little bit above it, but of course it's still tracking the same line. C continues on, and it's a little bit further because it had longer to go to reach it. So that's C dash. And B heads directly there and ends over at B dash. So we end up with, at the end of it, this is what our image becomes. Okay, so what's that? That's really, with axial symmetry, it's like you can fold it over. Okay, this is the line that you could fold the page over, and L should land on L. I have a feeling there that my L is a little bit too close to the line. So let's just cheat and pretend that the line was there. That looks a little bit more realistic. So that's what axial symmetry is. Okay. Let's answer some of these questions here. What it said, or it's asking us here, is it's asking us that ABD So this thing here, okay, maybe we should pick it in green just to make it obvious. This triangle here is the correct, the correct transformation is the image, so ABD is the image of ACD under what? Okay, so how would we get from this one here to the one over to the left hand side? Okay, how would we get from one to the other? How do we get from there to there? So what type of symmetry is it? Have a think about it, pause the video, don't jump straight in and have me say it. So what you are looking at here, if we take a black line, is we're looking at axial symmetry through there. Because what will happen is that B will go directly through there and back out the same direction. So B ends up here. Where does A go? Well, it's already on the line. So when you do axial symmetry, A stays at A, and the same is true of D. It stays there. So basically what happens is B flicks over to B dash. So your ABD is going to create this triangle here. Okay, and it's not just the endpoints where it works. You know, if you take this point here, send it directly to the line and back out the same direction, it ends up over there. So it ends up creating this other triangle here. So what we would say is the correct answer. Now you got to be specific as well. In fact, it even says that, be as specific as you can. They don't want you to say under just axial symmetry, although it is. What type of axial symmetry? Like, what line did you send it through? So you would say axial symmetry through, through the line AD. Okay, make sure that that is nice and clear for them. Okay, it now asks us a totally different question. So this is another one again that you should pause just to see, can you get right? It says AD is 10 centimeters. Let's put that there. AD from A to D is 10 centimeters. Can you get the length from A to B in surd form? Sorry, it's 10. I may have given away something there with that one. Hopefully that's nudged you into thinking, how can we possibly get this length here? So give it a pause, have a try. If you don't get it now in the next minute or two, just stick me back on, I'll try to nudge you again. Okay, so my little nudge is, what other piece of information have we been given apart from that particular length? From A to D being 10, was there anything else that we were told in the question? So if you hadn't got it the first time, pause it again, try that. Here is the little nudge. We're told that this is 60 degrees because we are dealing with an equilateral triangle. So it's asking us to find out what x is. We know that this is a right angle here. So what are we going to do? So it's trigonometry, of course. This is the opposite. This is the hypotenuse opposite and hypotenuse, which trigonometric function? Sine. So sine 60 equals opposite over hypotenuse. So that's 10 over x. I like this because, as an example, because this is the more difficult one. The x is on the bottom. You know, what do you do to solve this? So if x is on the bottom, what you want to do to get it off the bottom is you want to multiply both sides by x. The left hand side by x sine 60, and the right hand side, if you really want to show it, it's 10 over x times x, that's just 10. Okay. So we just get equals 10. We're trying to find out what x is, so we're going to divide both sides by sine 60. And you can just go to your calculator for that. Just make sure that you're in degrees mode. Okay, that there's a D on your calculator. So 10 over sine 60. And that is, and it said in surd form, so we're expecting a square root, and that's certainly what we get. 3, and these were, I think, did I mention centimeters? Yeah, so don't leave out the units. So there you go. So that's a small little revision of trigonometry as well as that there. Okay, here's one that I actually want you to do. I'm not going to do it out here. In fact, it's quite difficult for me to do. But it says it wants you to construct the rest of the Horcrux using the following facts. The line AD is a perpendicular bisector, so we're just after doing that. And thank you to everybody who sent in the work there. So here's your chance to try it out now. Get the perpendicular bisector of BC, draw that in. And it says that the circle at K is the intersection point of AD, so where AD intersects with the bisector of angle B. So what you want to do is you want to cut angle B, so this angle here, you want to cut that in half. And if you remember, AD was this line here. So you're looking for that particular point there. That's the center of the circle. Okay, that's the center of the circle, and so what you'll be able to do from that point there is you can use your compass then to draw this thing here. Okay, that's a pulling, but you get the idea. Don't know why I always go for a second shot of it. Oh, anyway, that's what I want you guys to do, if that's okay, and send it on to me. So it's 2018, it's paper 2. And it is question 12. So just take a photo. I'll stick it up as an assignment and you can send the photo into me. What I would also like you to do as well, there's no need to send this one to me. What I'll do is I'll make a little video for yourself. If you can give, this is, yeah, it's 2017. It's paper 2 and it's question 1. I have a feeling that we've looked at some of these before. I don't know if we did this exact one here, but I want you to fill in just these answers here, and I will make a little video of it for you so that you can see how you've done with it. Okay, gents, take care. All the best.